Okay, part 2 of this video is going to finish up with the last 2 proofs. In looking at this proof, this one looks a little different from proofs we have done before because there are numbers involved. And so we're going to do a little bit of combining of algebra with our traditional proofs. So given that AD is 6, DC is 3, BE is 4, and EC is 2, prove the triangles are similar. Picture is already marked for us. The problem is that this segment right here that we're given doesn't correspond to part of our little triangle. Okay, so we are going to need to do some algebra work because ultimately we need to say that CA corresponds to CD and that CB corresponds to CE. I'm given side length, that makes sense. There's no way to figure out that third side, so I'm not going to be doing side, 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 but I can see that I share this angle of C. They overlap, and so I'm going to have that reflexive. So I'm going to prove these two congruent by side angle side, similar by side angle side. So let's get started. So we got to get our given. AD is equal to 6, DC is 3, BE is 4, and EC is 2. Now, I need to get that CA and CB into my proof. So I'm going to go back to parts to whole, and I'm going to say that CA is equal to CD plus DA, and I'm going to say that CB is equal to CE plus EB. Now that I have those two in there, I'm going to do a little math substitution here, and I'm going to say that CA is equal to 3 plus 6, and CB is equal to 2 plus 4. That is by substitution. While it's tempting, we can't add those in the same step that we're substituting. Remember, one step per line. So CA is equal to 9 and CB is equal to 6, and I can do that by addition. Now I need to set up my ratio to show that these are proportionate, and so I'm going to say that CD over CA is equal to CE over CB. And what lets me say that is definition of proportions. I can take equal things and create proportions out of them. And so when I substitute, or when I got my sides proportionate now, and if I substitute in to show that their values indeed are, CD, I've got 3 over 9 is indeed equal to 2 over 6, and that is by substitution. Now my sides are shown to be proportionate in the same ratio. 2 more steps, we'll call this done. I need my angle. Angle C is equal to angle C. That is by reflexive. Remember, when we have overlapping or shared pieces, we use reflexive. And now I can say triangle CDE is similar to triangle CAB by side, angle, side similarity. The whole substitution and showing the segments are proportionate is a little tedious, but not hard. You just have to remember one step per line. Now our last proof. Okay, we're going to tackle this last proof. Now again, this looks like that cross product idea when we get to the bottom. So let's look at what sides we're talking about here. We're talking about AB, and we're talking about AC. And then we're talking about, for that triangle, we're talking about CD, and we're talking about DE. So those are the corresponding sides we're going to want to say are in proportion to each other. So now can we have our plan laid out? So let's figure out how to prove our triangles similar so we can go ahead and write the similarity statement, write this ratio, and cross multiply. So AC is equal to BC and DC is equal to CE is given. When I mark this AC and BC, CD, and CA, I see I have two isosceles triangles, which is going to kind of matter in a minute. Butterfly picture, I always have vertical angles. ACB is equal to angle DCE by the vertical angle theorem. Now I'm going to go ahead and write a ratio for, a proportion rather, for the sides that are given to me. Because I know they are equal, I can go ahead and set up that AC compared to CD is going to be the same ratio as BC compared to CE. And the reason I can do that is definition of proportions. I took equal pieces and I set them up in relation to each other. Now I have enough information to say that triangle ACB is similar to triangle DCE, DCE by side angle side similarity. Now I want to set up my set of ratios that are kind of like CPCTC. What additional ratios do I know after I've proven them similar? And the additional ratios I know after I've proven them similar, get our picture back up here, is that I know that AC is in proportion to CD at the same rate in which AB is in proportion to DE. That is by definition of similarity. And now I am just actually going to cross multiply and I will be done. AC times DE is equal to CD, times AB. And that is cross multiply. And that is that proof. Good luck with your homework.